Good morning, everybody. We are continuing with 4D, solving logarithmic and exponential equations. So on Friday, we looked at these steps for solving logarithmic equations. So step 1, isolate the logarithm so that it's in this form, log base b of a equals p. Step 2, there's two ways we could do this. We can either change to exponential form or exponentiate. Step 3, solve for x. And then step 4, check for extraneous solutions. Okay, and so we did a couple examples on Friday, and we're going to continue with more examples today. So we are on number 3. So we are trying to solve for log base 5 of 2x minus 3 equals 6. So step 1 will be to isolate. So the part that we're trying to isolate is the logarithmic part. So log base 5 of 2x. So the log and then what we're taking the log of, that's what we're trying to isolate. So if I'm trying to isolate this, the first thing we need to do is get rid of this minus 3. I also am going to need to get rid of the 4 in front, but I have to get rid of the minus 3 first. So to do that, I'm going to add 3 to both sides. So then we have 4 log base 5 of 2x equals 9. Then I have to still get rid of that 4 that's in front. The best way to deal with that is to divide by it. Right now it's multiplied by the logarithm, so I could get rid of it by dividing. So then we have log base 5 of 2x equals 9/4. You could put this as a decimal, 2.25. I'm just going to leave it as a fraction, 9/4. Okay, then, so that's step 1, is isolate. Step 2, we could either change to exponential form or we can exponentiate both sides. I'm going to go ahead and change to exponential form. That's the only way to get rid of a logarithm, is to change to exponential form or exponentiate, because we're trying to get rid of the logarithm and get the 2x part by itself. All right, so if I change to exponential form, this is the base. So log base b of a equals p. So step 2 is to change forms. So if I change forms here, I'm going to have 5 is the base, 5 to the 9/4 power equals 2x. So now notice the 2x part is by itself and there's no logarithm in the equation anymore. Now step 3 is to solve. Now if you prefer, you can evaluate the 5 to the 9/4 power first and then divide by 2. Or we can go ahead and get the x by itself here by dividing by 2. I'm going to do that, and then I am going to approximate this as well. So now to solve for x, I have to divide both sides by 2. And then we'll have the x by itself. So we'll have x equals 5 to the 9/4 power divided by 2. And as I said, I'm going to approximate that as well using a calculator. So we need some kind of calculator as long as it does exponents. Okay, so I'm doing 5 to the 9/4 power. I'm going to put 9/4 in parentheses just to make sure it divides correctly, or does the correct power on my calculator. And then divided by 2 gives me approximately 18.69. All right, and there's our solution. You could write it either way. since I'm going to have you be filling in your answers on Google Forms, you're probably going to just want to approximate. So don't forget the last step is to check for extraneous solutions. You don't have to plug it in to see if it works. You just have to make sure that if you were to plug in this case, 18.69 into this logarithm, that you're not ending up with a negative number. So if I plugged in the 18.69, that'd be 30 something, which is not negative. So I would be able to take the logarithm of that without a problem. All right, let's look at number 4. Log of 2x minus 5 minus 4 equals negative 2. Natural log, ln. So ln is still a logarithm. That stands for logarithm natural, or natural logarithm. And remember, that's a base of e. So step 1 is to isolate the logarithm. So the logarithm, and then the part we're taking the logarithm of, a 2x minus 5. So to isolate that, we add 4 to both sides. So then we would have natural log of 2x minus 5 equals 2. Okay, so that's step 1. Then step 2, we got to change forms. One thing to remember is that a natural log is a base of e. So on this one, the base is e. So this is the base log base b of a equals p. So when we change forms, it's going to be e to the second power equals 2x minus 5. And then the last step is to solve. So I am going to, I'm trying to get the x by itself. So here to get the x by itself, we add 5 to both sides. So I'm going to have e squared plus 5 equals 2x. The x is still not quite by itself yet, so I'm going to divide by 2 to get the x by itself. And notice I put this entire expression over 2 right here. So now we have x equals e to the second power plus 5 divided by 2. Okay, so that is one way to leave our answer. We can approximate that as well. Now, you do have to be careful that when we put this on the calculator, because the entire expression of e squared plus 5 needs to be divided by 2. So I'm going to use parentheses when I'm putting this in my calculator. Now, we do have an E button on a scientific calculator. So you do need a scientific calculator that has an E. So I am doing in parentheses, let me clear what's in there. In parentheses, we're doing e to the second power plus 5, close the parentheses, so it did all of that, and then divided by 2. And remember, e is just a number, and it's about 2.72. All right, so if we put that in our calculator correctly, we should have approximately 6.19. Okay, and again, both of these are correct. The e squared plus 5 over 2 is exact, and the 6.19 is the approximate. All right, we've got a couple more to do here. Number 5. This one we're going to have to use a little bit more of our algebra skills. Because you might notice there's 2 logarithms. So we have log of x plus 2 minus log of x equals 1. So step 1 is to isolate the logarithm. This looks a little bit different when there's 2 logarithms. The way we're going to isolate the 2 logarithms is we are going to condense these into one logarithm. So we have to use our properties of logarithms from the previous section, from 4C. So this is in the form log base b of m minus log base b of n. So when I put those together, it's still going to be log base 10 is the base here since no base is written, but it's going to be m divided by n since there's a minus sign in between. So when I write that, it's going to be log of x plus 2 over x, and then still equals 1. All right, so that's where it looks different, is that in order to isolate the logarithm so that there's only one logarithm, I have to condense those using my properties of logarithms. Step 2, so that's step 1. Step 2 is either to exponentiate or change forms. I'm going to change to exponential form, and remember this is a base of 10. The common logarithm is a base of 10. So if I change that to exponential form, it's going to be 10, which is the base, to the first power. That's the p over here, equals x plus 2 over x. Okay, so you have to change forms before you try to solve anything. All right, so now step 3 is to solve. And 10 to the first power is just 10. So I'm going to write that as just 10. So 10 equals x plus 2 over x. Now this, now I can try to solve. This is a rational equation. So to get rid of a fraction, hopefully we all remember, to get rid of a fraction, we have to multiply by the LCD. In this case, the only common denominator, the only denominator is x. So to get rid of the fraction, I'm multiplying both sides by x. So on the left side, now I would have 10x. On the right side, the reason we did that is to get rid of the fraction, and we're just left with x plus 2. Now we can just continue solving here. So I need to get x by itself, but right now x is on both sides of the equal sign. So I want to get the x's on the same side of the equal sign. So I'm going to subtract x from both sides. Remember, that's just like a 1x. So 10x minus 1x gives us 9x. So we get 9x equals 2. And then to solve, to get the x by itself, I'm going to divide both sides by 9. So we get x equals 2 ninths. Now, you can leave that as a fraction. That would be the exact answer. Or you could divide it. 2 divided by 9 is approximately 0.22. So you could do a decimal or leave it as a fraction. All right, so that one, in order to actually solve, we did have to know how to get rid of a fraction. And we also needed to know how to condense. All right, next one is number 6. So to deal with this one, there's a couple ways we could deal with it. We could change it right now since the logarithm part is technically by itself. I could change it to exponential form, but I would have 2 to the 15th power, which is pretty big. So instead of doing that, I'm going to deal with this exponent here, this 5. So we have log base 2 of 4x to the 5th power equals 15. Remember, the property we have with this is if we have an exponent, we can move it to the front. Okay, so if I do that, I'm going to have 5 log base 2 of 4x equals 15. Now, that seems to not help us because now the logarithm is not by itself, but it does help us because now I could get rid of this 5 by dividing. And so now I'm going to have log base 2 of 4x equals 3. So that was all part of step 1, isolate the logarithm. And now notice that's going to be a lot easier to deal with than what we had before. Then step 2 is to change forms. So to change this to exponential form, we'd have 2 is the base to the 3rd power equals 4x. Okay, so that's step 2. Then step 3 is to solve. I can evaluate 2 to the 3rd power, which is just 8. So 8 equals 4x. And then to solve for x, divide by 4. And we get x equals 2. Now, again, one thing we do want to remember to do is check for extraneous solutions and make sure if I plugged in any of these numbers that I wouldn't be trying to take a logarithm of a negative number. So if we plugged in the 2 here, 4 times 2 to the 5th power is not negative. So I don't have to worry about an extraneous solution. All right, our last problem for the day, number 7. So we have log of x plus log of x minus 3 equals 1. So step 1 is to isolate. Again, like problem number 5, this problem has 2 logarithms. So I'm going to need to condense these into one logarithm. That's what we're going to do in the isolating step. This is in the form log base b of m plus log base b of n. So these have a plus sign in between. So when I combine it into one logarithm, it's still log base 10 since there's no base written. And this is going to be m times n. So I'm going to have log of x times x minus 3 equals 1. Now, now it is condensed into one logarithm. If you want, you can distribute this x now and multiply x times x minus 3, or we can wait. I'm just going to go ahead and wait. All right, so then step 2 is to change forms, change to exponential form to get rid of the logarithm. Remember, the common logarithm or the logarithm with no base written is a base 10 logarithm. So when I change this to exponential form, it's going to be 10 to the first power equals x times x minus 3. And now I want to solve that. In order to solve that, so step 3 is to solve. Instead of writing 10 to the first, I'm going to just write 10. 10 to the first power is 10. And then, as I said here, I am going to distribute, and that's going to give me x squared minus 3x. Now, once again, this is a different type of equation to solve. This is a quadratic equation. So our go-to methods for solving quadratics is we want to try to factor. But before we try to factor or use quadratic formula, hopefully not, but hopefully factor, we have to get one side equal to 0. And that's true anytime we're solving in a quadratic. So I'm going to subtract 10 from both sides to get one side equal to 0. And then I'll have 0 equals x squared minus 3x minus 10. Now I can factor that. So when I'm trying to factor, I'm looking for numbers that multiply to be negative 10 and add up to negative 3. So I can use 5 and 2. I'm going to need x minus 5 and x plus 2. And then it's still equal to 0. Once we factor, don't forget we have to now set each factor equal to 0. So x minus 5 equals 0 and x plus 2 equals 0. And solve each one of those. So to solve this one, I'm going to add 5. So we get x equals 5. To solve this equation, I'm going to subtract 2. So we get x equals negative 2. Okay, so that's step 3. We solved. In this case, though, we did end up with a quadratic equation that we had to solve. And then in this one, especially because there's 2 answers, remember that in step 4, we have to check for extraneous solutions. So that means there's one of these that probably is not going to work. If I look at my original equation, log of x plus log of x minus 3, we can't take a logarithm of a negative number. So we have to make sure if we plug these numbers in that I don't get a negative that I'm taking a log of. So if I plugged in a 5, this would just be log of 5, which is allowed. And then if I plugged in a 5 here, this would be log of 2, which is fine. They're both positive. So x equals 5 is going to work. However, If I plugged in a -2, right here we'd have log of -2. And if I plugged in a -2 here, we'd have log of -5. I can't take a logarithm of a negative. If we try to do it on our calculator, like if I try to do logarithm of -2, it says invalid output. So this one, since I would be plugging in a negative and taking a logarithm of a negative, I can't actually plug that one in. It doesn't work. And so what that is called is extraneous. So this one, number 7, only has one solution, x equals 5, because the other one, x equals -2, is extraneous. So we're going to stop there. Now we have seen lots of different logarithmic equations, and tomorrow we'll see some exponential equations.